Hello everyone, my name is Gong. I am a research scientist at Apple. Today I'm going to talk about Acustico, surface type detection and localization using wrist-based acoustic TDOA sensing. This work was done during my internship at Facebook Reality Labs, where I was advised by Aakar and Benko. Before I go into the details, first of all, I just want to quickly show you what is Acustico and how it works. Acoustico is a passive acoustic sensing approach that enables tap detection and 2D tap localization on instrumented surfaces using a wristworn device with 2 accelerometers and 2 microphones underneath. For example, in this AR calculator app, user can input numbers on any surfaces nearby and get the calculation results. So before I dive in, first of all, let me briefly explain how Acoustico works. When a finger taps a table, vibration can propagate outwards from the point of contact through the air, which we call sound wave. This is in contrast to the vibration propagates through the surface itself, which we call surface wave. We use 4 sensing elements on the bottom of the wrist to detect when the leading edges of the surface wave and sound wave reach them separately. 2 microphones on the front sense the sound wave, while the 2 accelerometers on the back sense the surface wave. Based on the time differences of arrival between each pair of the sensors, we localize the taps in 2 dimensions precisely. So time differences of arrival analysis have been already used in many existing works. However, we are the first to embed acoustic sensors in a wristband form factor to detect and localize finger taps. The wristband location and form factor introduce 2 primary challenges. First is the small distances between each pair of the sensors, which makes it hard to estimate the TDOA difference. To mitigate this issue, we first included both accelerometers and microphones in our wristband. Since the propagation speeds in the surface and air are different, this could actually add extra time difference and improve the sensing resolution. Please refer to our paper for a detailed explanation. And we also selected highly sensitive accelerometers and microphones in our wristband prototype and leverage a DAC that can support as high as 1 MHz sampling rate. Here's our wristband prototype. 2 accelerometers and 2 microphones are situated on the bottom of the wrist with a mechanical structure. And further, the second challenge of a wristband form factor is the inconsistent coupling between the sensors and the surface, which highly depends on how users put their hands on the surface. To allow for more tolerance, instead of using mathematical triangulation, we choose to use a machine learning regression model to estimate the tap's 2D coordinates. Before I talk about the evaluation, let me first show you a short demo video. As you can see here, the system can detect taps using a simple threading algorithm based on sensors readings, and 2 independent regression models for both axes are used to interpret the tap locations in 2D. Next, let's briefly talk about evaluation. To validate the accuracy and robustness of our sensing system, we tested our system on 5 different surface materials using 2 tap methods and 2 hand configurations. Results from 20 participants show that our system can achieve precise 2D localization across all different test conditions. Finally, we built several demo applications to showcase the possibilities of Acoustico. The first application we built is a dial pad for AR devices. User can simply tap at different locations to enter a phone number and call the person he or she wants to contact. We also built a Wreck 'em More AR game. User can hit the mouse by tapping on the surface, which offers an immersive gaming experience with corresponding haptic tactile feedback. Finally, we combined Acoustico with an optical flow sensor underneath to additionally track the user's forearm motion on the surface. Using the optical flow sensor, we created a mouse experience where a user simply moves their wrist to control the pointer position. Left and right mouse click are invoked by either the left or right spatial location with respect to the wristband. With that, I would like to conclude our work with 3 take-home messages. We present a passive acoustic sensing approach for wristworn devices to detect and localize taps. Our system can reliably detect taps and yield high localization accuracies across different surfaces. We believe Acoustico holds the potential to further enrich the input expressiveness of computing devices. That's all I want to share about Acoustico. Thanks for listening.